Hello everyone, this is going to be a fluids video, and in this video we're going to be covering the Buckingham Pi Theorem. As you can see here, we have a problem from chapter 8 of the fluid mechanics book by Hippler, and we're going to be doing number 35 of the practice problems here. So the question reads, the thrust T of the propeller on a boat depends upon the diameter d of the propeller, its angular velocity omega, the speed of the boat v, and the density rho and viscosity mu of the water. Determine the relation between T and these parameters. Okay, so what I'm going to do here is I'm going to go through the process of how we solve these kinds of problems. So the first thing we do here is we're going to want to define the physical parameters. Okay, so we're going to specify n, and this is going to be the physical variables. So in our case here, the variables we're going to have is we're going to have the thrust T. We're going to have the diameter d. We're going to have omega, the angular velocity. We're going to have regular velocity, density, and viscosity. And in total, that's going to be 6 variables. Okay, we're also going to want to define m, and this is going to be the number of primary dimensions. So recall, primary dimensions are mass, length, time, and temperature. So in our case here, these 6 variables, all of them combined, they all form a mass term, length, and time. So now we have 3 primary dimensions. Okay, and what we call pi groups, these are just dimensionless assortment of the variables that are defined in our problem. To get the number of pi groups, it's simply going to be n minus m. So that means in this problem, we're going to have 6 minus 3. So we would have 3 pi groups. So we're going to have 3 arrangements of the variables that give us dimensionless products, if that makes sense. Okay, so from here, we're going to want to write out the primary dimensions for each variable. So we have thrust T, and that's going to be a force. So primary dimensions of force is ml T to the minus 2. We have a diameter d. And that's just the length. We have angular velocity, omega, and that's rads per second typically, so it's just going to be t to the minus 1 because radians are unitless. We have velocity, length times time to the minus 1. We have density, mass over volume, which is length to the third, and finally viscosity. This is mass times length to the minus 1 time to the minus 1. Okay, now our next step here is we're going to want to select variables that are going to repeat, meaning that these variables are going to appear in all 3 pi groups, or could possibly appear in all 3 pi groups. So we're going to select the repeating variables. So we have 6 overall variables. since n is equal to 6. So we're going to select an m quantity of them. So in our case, m is 3, so we're going to have 3 repeating. And the only rules for selecting those 3 repeating variables is that as a combination, all 3 of those variables have to have all of the base dimensions. So whichever 3 variables we pick, they all have to combine to have mass, length, and time between the 3. So typically we would select the ones with the simplest combination of dimensions. So in this case, let's just say that our repeaters. So we want the simplest, so let's go with diameter as 1. And we can also say angular velocity is another. That's pretty simple. And then, so right now we have length, we have a time, but we're missing a mass. So let's go ahead and put density as our last one, since that gives us our mass term. Okay. So now from here, we can actually go ahead and start finding these pi groups. So that would be our step 3 here. So from the remaining n minus m variables, so all the 3 other variables that is not diameter, angular velocity, or density, we select one at a time. We call this variable q. So we select a q variable. And obviously that's a non-repeater. And with this q variable, we multiply the q by the repeaters. And the repeaters are going to be raised to some unknown exponents. And we're going to let q just be raised to the first. So I'll go ahead and run an example real quick here. And we're going to do this 3 times. So we're going to have 3 q's, one for each pi group. So for instance, pi group 1, we're going to write out our repeaters here. So diameter d raised to some unknown a exponent. Our angular velocity omega raised to some unknown exponent, as well as density. So let's do density to the b, omega to the c. And then our q. So in our case, our first q, let's go ahead and just say that's going to be thrust, because our diameter here is a repeater. Angular velocity is a repeater. Density is a repeater. So then we're going to thrust to the first power. Okay, and now we're going to write this out in terms of their primary dimensions. So we're going to have length to the a times densities mass to the b, length to the minus third times b, and then omega is going to be t to the minus, usually minus 1, but we have a c here, so minus 1 times c. And then the thrust is m to the first, L to the first, t to the minus 2. And that's all going to equal 0. So the reason the reason that our exponents are going to equal 0 is because we want this to be dimensionless. So we're going to want it to be unitless at the end. So what we're going to have to do here is we're going to have to solve it one primary dimension at a time. So for instance, for the m term, what m terms do we have here? Well, we have m to the b, so this is going to be 0, since we want it to equal 0, is going to be b plus 1. So then we get that our exponent b has to be equal to -1 in order for that to be dimensionless. So we just do this for all three. So 0 is equal to, we have an L to the A here, so it's going to be A plus 1, or I'm sorry, I forgot the 3b, minus 3b plus 1. So we get A is equal to -4. And similarly, we do the same for time. So what we're doing here is we're combining the exponents for each primary dimension and setting that equal to 0, since again we are trying to get this to be a dimensionless. So for t we're going to have -c, -2. So we're going to get c is equal to -2. So from here we have our exponents for this first pi group. So now we can rewrite our pi1. So therefore pi1 is now equal to d to the a power, and we said a is equal to -4. Density to the b power, that's equal to -1. Omega to the c, which is -2. And then thrust, again, we're just leaving as to the first power. And then from here we can clean it up a little. So we'll have thrust divided by d to the 4th rho omega squared. So that's going to be our first pi group. And if you want, you can go ahead and check the units, and it should come out to be unitless. So I'm going to just go ahead and do my other pi group here. So we do the same thing here. So pi2, should label this Q1. So pi2, again, we put our repeaters, d to the a, rho to the b, omega to the c. And then we're going to pick a Q2 here. So we already used thrust for our Q1. We can use velocity or viscosity for our Q2. So let's just go ahead and do velocity for this one. So it's going to be velocity to the first. And if I write out the dimensions of this, L to the A for D, mass to the B, times length to the -3 times B, T to the -C, L to the first, T to the -1. So that's velocity. That's omega. That's density, and this is diameter. So again, we're just going to set a system of equations here. So for m, 0 is going to equal, well, we have an m to the b, so b, and then we don't have any more m's. So that means b is equal to 0. For L, 0 equals a minus 3 times b plus 1. So since we said b is equal to 0, we can just say that this is 0. So then we get that a is equal to -1. For t, 0 is equal to -c minus 1. So we get that c is equal to -1. Okay. So then our pi2 is now d to the a, which is -1, rho to the b, which is 0 now, omega to the c, which is -1, and then velocity, again, just to the first power. So then we get pi2 as velocity over d omega. All right, and then last but not least, we're going to do the same process for pi 3 here. So if you had more than 3 pi groups, you would just do the same process for all your pi groups. Essentially, the only thing that would change if you have more pi groups is going to be your Q. So your repeaters are always just going to be your repeaters in the beginning, and then your Q would just be that last term that we're adding in at the end. Or I'm sorry, that we're multiplying by at the end. Okay, so pi 3, again, let's write our repeaters, d to the a, rho to the b, omega to the c. And then our last Q, the only one left, is viscosity. So let's just mu to the first. Writing out the base units here. LA, m to the b, L to the minus 3b, T to the minus c. And then viscosity is just going to be m, L minus 1, G to the minus 1. Okay, so for m, we have 0 is equal to b plus 1. So we get b is equal to negative 1. For L, we get 0 is equal to a minus 3b minus 1. So since b is negative 1, we get minus 3 times negative 1 minus 1. So if we solve that out, we get that a is equal to negative 2. And then for t, you get 0 is equal to negative c minus 1. So you get c is equal to negative 1. So then if we write this out and solve for pi 3, we get d to the a, which is minus 2, rho to the b, which is minus 1, omega to the c, which is minus 1, and then just mu to the first. So then pi 3 is simply going to be mu over d squared rho omega. So now we have our 3 pi groups, but we're not done yet. All we've done is find our pi groups. So the question still asks to determine the relation between t and these parameters. So let's pull that down here. So since they want the relation between t and these parameters, we're going to have to write t as a function of these parameters. So what we can do right now is we know that each pi group is a function of the other pi groups. So we can say, since they have the same units, since they're unitless altogether. So we can say that the first pi group, t over d to the 4th rho omega squared, is equal to some function of the other 2 pi groups. So v over d omega, comma, mu over d squared rho omega. Now with that, since they want a relation between t and the other parameters, we can simply just solve for t. So we move the denominator to the other side. So we get t is equal to d to the 4th rho omega squared multiplied with some function of v over d omega as well as mu over d squared rho omega. Let's make that a little nicer. Let me rewrite that. So now we have a relation between t and the other parameters here. So that is our final answer. Hope you guys enjoyed.